So under behavioral description, we are going to see how a state diagram can be drawn, how to apply a state diagram in an application, defining a sequence diagram, and understanding the concepts seen in sequence diagram. So behavioral description, it always comes with describing the states. State can be many states. There will be a time of transition from one state to another. So that can be determined using this arrow mark. Okay. So behavior can be specified by state machine. A can be the first state, B can be the second state. So changes from one state to another. So from A to B can be called as events. Okay. So when we change from state A to state B, it is called as events. So this is the general diagram, how a state diagram look like. Okay. So here you can see as the right side folded corner, which is called as comments from the UML notation, it says that this is, the first one is called as A. A is what? It is a state. B is a state. And the square pattern, it describes the name of the state. The name of the state, it may be either an alphabet or it may be a number, 1, 2, 3, or it can be some other names also. You can give some other names also. So changes from one state to another are triggered by the occurrence which is called as events. Okay. So now, what do you mean by event? An event is some type of action, an action which makes an event, right? The event may originate outside the system, such as a user pressing a button. So what example we were seeing so far? After the GPS moving map, we started seeing mouse clicking operation. So under the mouse clicking operation, what kind of operation is taking place? Clicking a mouse is an event, right? So what kind of event it is? The event is originating outside. Who is clicking the mouse? Some of the user is clicking the mouse, or you can say user is pressing a button. That is an outside event. Okay. The event may originate outside the system, such as a user pressing a button, or it may originate inside, such as when one routine finishes its computation and passes the result on to the another routine. So the event can also be run inside the system. So when it happens inside the system, you have written many sets of program lines to control the microcontroller, right? So now, after checking some kind of criteria, the first event, the microcontroller, it has a set of program or codes to run the second event. After it completes the first event, it is going to check for the second event, right? So this, it happens when the event is running inside the design, which is unknown to the human being. Or you can say it is not initiated. This event is not initiated by user pressing a button. Okay. So types of event. Under the types of event, you have three types of event. The first one is signal. Second is called as call event. And the third one is called as timeout event. Okay. A signal is what? A signal may be user pressing a button. It is a kind of signal. Or when an amount of radiation is being sensed from the IR sensor, it is an event. Something is detected, right? That detected is what? That detected is a signal which can occur asynchronous. Okay, it is not synchronous, it is not continuous. The signal is not a continuous signal. It can be a discrete signal or a discontinuous signal. So asynchronous in sense, synchronous means it depends upon the time, right? Asynchronous means it doesn't depends upon the time. So a signal can be said as a asynchronous occurrence. It can occur at what time, whatever the time it may be, right? So now the next type of event is called as call event. So what happens? This happens in between the routines or the procedures inside the programming structure. Okay, a call event follows the model of a procedure call in a programming language. So inside the programming language, a call can be given to the a second event or the third event with the help of the first event. So what happens? As soon as a call is being given to the second or third event, what happens? An event happens, right? A signal is what? It is an asynchronous occurrence. It is often it is from the outside world by user pressing a button or some kind of deduction happening. A call event, it happens inside the world by calling a programming language. And there is one more event which is called as timeout event. A timeout event causes the machine to leave a state after a certain amount of time. Okay, so what happens when the time expires? The event will be leaving the machine, right? The machine will be leaving the particular event, or you say a timeout event is set to a particular time. After that particular time, it is been expired and the machine is expected to leave a state after that period. Is that okay? Right? So types of event: a signal, a call event, as well as a timeout event. So here there is an example given, the same example mouse clicking operation. In the structural description we were discussing about UML notations under the display. The display is what? The display is a it is an class which finally displays a pictorial representation in forms of pixels, or when the mouse is clicked, where the mouse is, it is based upon where the mouse is being clicked. If the mouse is clicked in the menu items, what happens? A navigation button will be there, or if the menu item is clicked somewhere else, sometimes some different page may open. So opening a page is called as drawing a box. Okay, so here always the start state is indicated with a dark circle. Okay, and the stop state is indicated as a dark circle surrounded by another circle. Okay, so start state, that's what they have written here. The comment box says the state has been start. To indicate the start state, you have a dark circle. To indicate a stop state, you have a dark circle followed by another circle which indicates the state has been finished. So to start the state, we are starting from the dark circle, and mouse click the mouse for what purpose? Finding the region. After clicking the mouse, the the desktop is supposed to, or whatever the screen you are working with, it is supposed to look for the region, what region it is. So after region is been found, at which spot the mouse is being clicked, go to the menu item. Check the menu item. There is a certain codes of menu items to ensure which page should be opened. Okay, so now after the region being found, it goes to the menu item, okay, and check which area is being clicked. Okay, so after checking which area is being clicked, it calls the menu item, the particular item. Okay, so this happens. At the same time, there is another possibility. When the region is being found, it directly founds an object, it highlights the object, and then it finishes. Okay, so what is happening, sometimes when you are clicking with the help of mouse, you will be navigated to the next page with the help of menu item. The menu may be having different pages. At this spot, when the mouse is being clicked, it goes to draw a new box. Okay, and sometimes it doesn't happen, instead it will highlight the particular object where it is being clicked. Okay, so highlighting or calling the menu, those things are called as events. And after that, the event is what? It's only what? Mouse clicking operation. So after clicking mouse, what happens? The event is being finished, right? So we are going to the stop state. Okay, right? So till now we were seeing about the state diagram. The next one is called as sequence diagram. So sequence diagram is the time parameter which flows vertically, whereas time typically flows horizontally in a timing diagram. I think in microprocessor based system you might have learned timing diagrams where how the timing diagram it looks like. It looks like drawing the timing diagram horizontally. So this is an example of microprocessor timing diagram. It says about some addresses A0 to what A15, like that. Okay, some kind of timing diagram representation. Whereas here what happens, here what is happening, a sequence diagram is the parameter which flows vertically. So vertically means in this direction. Okay, so now let us see how this sequence diagram look like. So this is the example of drawing the sequence diagram. Okay, a sequence diagram is designed to show a particular scenario or choice of sequence, shows what happens when a mouse is clicked in the menu region. The same example only like what we were learning under the state diagram. So now it has the three classes, that is clicking the mouse, that is one event, and displaying something, and there finally you have the menu. So mouse is what? Mouse is one class, display is another class, and menu is another class. So you are interacting with three classes and the objects are M, D1 as well as M. So these are the objects. You can clearly see it is represented with what? The comment box which shows the object, right? So what should be the first event that takes place when clicking the mouse? Clicking the mouse is the first stage, right, or the first event. So what is happening after this is the time frame taken to click a mouse. Time frame taken to click a mouse. So mouse clicking is finished. So after mouse clicking is finished, after pressing the mouse button, what happens? Display, it displays something. So here the time taken for the display will be long when compared to the mouse click. You all know when you click the mouse, what happens? At that second, fraction of second itself, that task is finished. That means another task is provoked after clicking the mouse, which makes the changes in the display. So the time frame taken for this task will be more when you compare to the mouse click class, right? So here the display, it depends upon the menu item, which item should be drawn, and it called the menu item. So it decides where the mouse click operation takes place, at which point. After that it calls that particular point. Okay, that's what for two things the display is working. for a long time. Okay, so now the menu is the last one. Menu, which menu? It has a time frame, and calling a menu, it also has a time frame. Okay, you can see the comment box says that focus of control. These tiny rectangular boxes are called as what? Focus of control. And you can see the dotted lines here, right? So these dotted lines are nothing but they are the lifelines. And when you see, even after the mouse clicking operation is finished, it will be available. The lifeline will be active until all the events are completed. Okay, and you can see the direction of the timing. The direction of the timing flows vertically downwards, right? The direction of the timing, it flows vertically downwards, which is explained here, right? So a sequence diagram, it contains some comment boxes as well as focus of control, lifeline, okay, and the time frame. It may run for the particular classes. Okay, so this is an example of a sequence diagram showing the mouse clicking operation as well as what the display will be displaying after the mouse clicking operation. Okay, so here you can see what is the purpose of the lifeline. So the purpose of the lifeline is what it is. It shows how long the object is alive. Okay, so in those you can see there are three categories: mouse, display as well as menu. All the three categories will be alive until the task is completed. Then you have focus of control. Those are the time frames. So it determines when the object is actively progressing. Okay, so that's all about sequence diagram. Okay, so till now we have seen structural as well as behavioral description. So we are done with unit 1. So there is one more example which I am not going to share now. Okay, of course you are going to do it by yourself. So you are going to draw the state diagram for operation of ATM machine. That is the task for unit 1, and later on when you submit the task properly with your same idea, with your unique idea, maybe you may receive some special marks. We can discuss that later. Okay, I'll be giving a task related with the state diagram, how to draw a state diagram by considering the real-time system. Okay, I'll be posting soon. So that's all about unit 1. In next lesson we can say about unit 2.